Right, thanks everyone for coming. This is MongoDB 101 tutorial. We're going to cover a few things today, starting with a brief introduction to MongoDB. Then we move on to some concepts, how MongoDB is different from other databases. We'll cover how we can install MongoDB from scratch, some basic commands for querying, updating, deleting, things like that. We'll have a look at indexing in MongoDB and how it's different from other databases. We'll also cover replication, high availability, how we monitor the database, as well as basic backup and recovery procedures. And finally, we'll dig briefly into the topic of scaling. My name is Ivan. I'm a senior architect and trainer at Percona. I specifically work with MySQL and MongoDB technologies. And in the picture, you can see me in the glaciers in the southern part of Argentina. Highly recommended if you get a chance to visit. Percona was founded in 2006 by Peter Zaitsev and Vadim Tkachenko, and we're one of the top experts in the world for open source database platforms. Okay? So let's get started with a brief intro. First of all, we might be wondering why one would use MongoDB over other offerings, right? As we know, MongoDB, at least the community edition and Percona releases, are free and open source. So you don't need to purchase a license. You can see the source code, modify whatever you need. It's very easy to begin with. As you will see, you can install it with just a few commands. And there's no complex prerequisites like you get with like Oracle RAC, for example, where you have to do a lot of things before you can start working with the database. Well, that's not the case here. The traditional databases come with a predefined set of columns, which sometimes has some complexities. But MongoDB is flexible, so you don't need to define a fixed structure for your data. You can modify things as it changes. You don't need any external products to scale with MongoDB. You have everything you need built in within the database itself. You don't need to combine with other products. Okay? Of course, all of these advantages wouldn't mean anything if the performance was not good out of the box, right? So a brief history of MongoDB. It was originally created by a company called Tengen in 2008. They were heavily using JSON back in the day. And they wrote their own database that used memory mapped files for dealing with that use case. Initially, it was built just for internal use, but people really liked it, so it became a full-fledged product shortly after. And they even decided to sell it outside. So that's how we came to be. When should you use MongoDB specifically? Well, if your data has JSON or is based on JSON, that's already a hint that MongoDB could be for you. If your data is changing often, having MongoDB means you will not need to do any schema changes that are expensive in other technologies. And as I said, you have everything you need to scale both reads and writes within the product itself. So you don't need to use any external products for that. Also for sharding, right? If you have a significant amount of data or a high throughput environment, those are also good use cases for MongoDB. Things that are great about MongoDB, the documents are atomic, so when you are changing a document, it's either fully changed or not changed at all. There's no need for joins, at least that's in theory, right? The idea is to store data more in a denormalized format in MongoDB versus other databases. However, they recently introduced a tool for joining, so people were really asking for the ability to do that, and so now you can join, although initially it was not the idea. As I said, you have the ability to do high availability and sharding directly with the product, comes out of the box, and you don't need any third-party software, right? Also, there are some interesting things to control the data life cycle. So you have built-in capped collections, which act like a circular buffer. So you start writing, and then when it's full, the oldest data is automatically removed. And then TTL indexes is another feature that lets you automatically expire data after some time has passed, which can be handy for certain use case. Other things that are not as cool, there's no schema, which is both a benefit and a downside because your data can quickly get out of control. The newer versions have the ability to enforce a specific schema for a collection, as we will see, but initially there was no way to do that. So as you can see from what I'm saying, some of the things that initially were not available are starting now to make MongoDB become a bit closer to OLTP traditional databases. So the difference is becoming smaller, right? There's no foreign keys in MongoDB, so you cannot relate tables to each other like you can in traditional databases. And MongoDB uses a proprietary language, which is not SQL. We will see this in the presentation, okay? So there's a learning curve, but it's not so difficult once you get a hang of it. The objectives when MongoDB was developed was to be a database that could be good for a cloud environment, distributing things, or an Internet of Things use case that you could easily scale both horizontally and vertically, and to develop a database that is good for agile development scenarios or methodologies, and that is able to also represent data types that don't exist within the JSON specification. There's a few different flavors of MongoDB. First, you have the Community Edition that MongoDB releases. Then there is the Enterprise Edition, which comes with some extra features like LDAP integration or encryption and auditing. And then Percona releases their own version of MongoDB, which is based on the Community Edition, but also provides an implementation of the enterprise-level features free of charge. We have also a memory storage engine that is not available in Mongo Enterprise, the hot backup functionality, and some extra options for the profiler. So it's definitely worth testing that version over Community. There's also the possibility to have MongoDB as a service. The most commonly known is Atlas, which is the MongoDB offering. It has some extra features like integrated full-text search. Also, you have online data archive, which means you can move some of the older data to an S3 bucket, for example. And also a feature called Atlas Data Lake that is for analytics use case. Then AWS has DocumentDB, which is compatible in the protocol level with MongoDB, but behind the scenes, we don't know what that is. And Microsoft has Cosmos DB, which is an emulation API for the MongoDB wire protocol as well. In order to connect to MongoDB, there's many clients available. The most common is the Mongo Shell, which comes with MongoDB. But there are also some graphical tools as well. Compass is the one that MongoDB distributes. But there's also Studio T3, which is another nice alternative. And Atlas has its own web interface, which you can use to connect. And this screenshot is specifically of Compass, in case you were wondering. Let's dig into the concepts real quick. So from top to bottom, we'll have at the bottom level the MongoDB instance, okay? an instance can contain one or more databases. So it's a container for databases, okay? Then as we go up, each database will have one or more collections, which in turn have documents and indexes. So let's see each of these concepts in a bit more detail. The MongoDB instance is basically the MongoDB process at the operating system level. This is in charge of doing the memory management as well as interaction with the clients to run the queries and stuff. And it will operate with the files that live on the disk, which are your database files, okay? The way to interact with the instance is to use a client like MongoShell or any of the ones that we just saw. So if you run the PS command, for example, in your system, you will see that there is a MongoDB process and a configuration file that it's using, right? So with this command, you can check the process. If you're already connected to the instances that we have, you will not see any process yet. It will be our job to install it and run it, okay? For those of you that are right a little bit after, I'll explain how to connect in just a few minutes, okay? So a MongoDB database is a set of files on disk. The default directory is under /lib mongo, but you can change this if you want. And here you will see the files for each of the collections plus the indexes. Depending on how you configure MongoDB, you might also get separate subdirectories for each database inside this root directory, let's say. Remember, again, we can have multiple DBs per MongoDB instance, okay? The collections is what would be similar to a table in a traditional relational database. Basically, it's a group of documents, and a single collection belongs to a specific DB, always, okay? As I mentioned, you can create a capped collection based on the size of the collection, so you can say this collection will be 500 megs, tops, or you can also create a capped collection with a number of documents. So you can say, I want no more than 10,000 documents, for example, okay? And another thing that is different is that if you start writing to a collection that doesn't exist, MongoDB will create it for you automatically. Remember, there's no schema here, just a container. So MongoDB can create it without knowing what you will put inside. Indexes are B-trees in MongoDB, similar to other databases, nothing really different. And as we know, an index is similar to the index in a book, right? It allows us to quickly get to a specific place we want. In this case, it will be a specific document inside the collection. And as is the case with most databases, indexes are great for speeding up reads or making you be able to get to your data faster, but you have to keep in mind that it adds a cost to any write operation, okay? Because when we insert a document, we'll need to update the index to make sure that it has that document, right? So if we have many, many indexes, it will become more and more expensive. Finally, the document is similar to the record of a traditional database or the row. And in case of MongoDB, it consists of key value pairs. Each of the fields has a type, okay? A BSON type, actually. We'll see this in a second. BSON is a standard that extends JSON with some special types that are not available. And there is a maximum size per document of 16 megabytes in Mongo, okay? Recent versions also introduce the ability to have some kind of schema. So this is called validation rules. You can get a collection to match just some specific rules, for example, to ensure that you always have a specific field in the collection so that your data follows some structure at least, okay? Here's a comparison between MongoDB and the traditional SQL databases. Like I said, the instance is the instance everywhere, same as the database. The tables are called collections in Mongo. The indexes are the same. And then a row or a record would translate to a document in MongoDB terminology. Finally, the column is normally referred to as a field in MongoDB. As I mentioned, MongoDB uses the BSON format, which is a binary form of JSON. And the idea is that it will add some types that you don't have in JSON, like, for example, binary or date. And the MongoDB driver will handle this conversion for you. So you don't need to deal with the mapping. It will be handled automatically. This is a comparison of the BSON and JSON types. For example, the number type in JSON is implemented as int32 in BSON. And you can see, for example, that the 64-bit integer type is not available in JSON, and BSON does implement it, as well as binary, object ID, and date. Okay? The rest of the types are the same as JSON. There's a specific field in MongoDB that is called _ID, which is the only field that is required by all documents by default. This is because this field helps identify a specific document within a collection. Okay, so it kind of acts like a primary key. If you don't provide this field when you're inserting, it will be automatically generated by Mongo. And if you want, you can customize it. And it can be any BSON type of the ones that were in the previous slide, except array. Okay? By default, it will be created as object ID. And I'll show you how this looks in a minute. Okay? But just remember that the _ID is kind of like the primary key, and that is required everywhere. Okay, so that's enough about concepts. Now let's dig into how to install MongoDB. There is a website that you can get to from your laptop. Here's a bit.ly link. So it's bit.ly/percona training. If you want to go there with your laptop, you will see a list of teams. There are stickers in the room. If you don't have any, you can grab the one nearest to you. And in the back, you will see the team ID that you have. So everybody will have their own instance. The slide says that teams 1 to 3 are reserved for instructor, but don't mind that. You can use those as well. And I will show you how to connect in just a second. Yes, it should be the one there, I think, unless they change it. Cool. So let me show you, let me give you a few minutes to connect, and I will show you the page in the meantime. So here's what you should see. When you go to bit.ly/percona training, you'll see team ID, and you can grab the public IP to connect. There's a link in the bottom to a zip file with the SSH keys in both Linux and Windows format. And you have to use CentOS user to connect and the public IP, okay? If anybody has trouble connecting, just raise your hand and I'll be happy to help. I will also show the examples here in the screen if you just want to follow along. Yes. They're running CentOS 7, and they don't have anything installed yet. I'll just grab this one for myself. Anybody has 23, just in case? No, okay. Then I'll grab that one. So if you run in Linux, this is how you would connect, okay? Just run SSH CentOS at your public IP, then -i and the key, the SSH key, okay? Say yes here, and you should be connected. Is the size of the text good enough for you in the back? It's okay? Okay, thanks. Anybody had trouble connecting? Just raise your hand. Yes. Right. So, to install MongoDB, there are several options. The easiest one, and the one we're going to do for this tutorial, is to use the per kernel repositories. There's also some repositories from MongoDB. You can compile MongoDB yourself if you want, or you can download it from the website, right? But let's do it the sysadmin way, let's say. Some important path for you to be aware of. The default data directory is /lib mongo. MongoDB config file lives under etc, and it's called mongod.conf. And you can find the logs in /log mongo /mongod.log. So for Red Hat, which is what we have here on our tutorial instances, the instructions are pretty easy. You will need to, first of all, install the per kernel repository. We're going to use the per kernel version of MongoDB for this demo. So basically, you will have to run yum install and use the URL of per kernel repository. This you can get from the per kernel documentation page, or you can simply type repo.perkernel.com/yum/perkernel release latest.noarch.rpm. Okay? So I'm going to follow along with you. By the way, you should probably sudo first to root, okay? So you don't get prompt for password every time. So do sudo su dash and hit enter. Okay. Let's see if it works. Okay. Let me show you the command one more time. This is what you have to do. Let me know if it worked for you. If not, just raise your hand. Good, thanks. So what this will do is basically create a file under etc repos.d whatever with some information for the per kernel repositories. What you have to do next is enable the specific repository that we have for MongoDB. And for this tutorial, we're going to use the latest version, which is 6.0. So I'm going to do just that next, and feel free to follow along. Okay. So it's basically per kernel release is the command. If you type it like this, it will show you some help. Okay. But if you do per kernel release enable per kernel server MongoDB -60. If you run this, you should get a message saying that the repository for the specific version is enabled. All good for now? Great. And the last command would be to do yum install. You can do -y to avoid being prompt for the yes or no. And then per kernel server MongoDB, like this. You will see this is actually a meta package that contains a couple of other things. For example, the Mongo shell, which now comes separate from the database itself. It used to come in the same package before. Then there's the server package, which is the actual MongoDB server. And you will see the tools also being installed. It has a few extra things. And finally, MongoS, which is the router that is used for sharding with MongoDB. So by doing the meta package, you will get everything. Okay. Did it work so far? Yes. If anybody has trouble, just raise your hand. Okay. So the only thing left now is to just start the service. Okay. So let's do systemctl start MongoDB. It didn't give any error, so I assume it started. But let's just check to be sure. Okay. Oops. Here. Okay, it says it's active running, so we should be good. And if you're curious, you can see here a few things like what is the systemd file that is used by this service, and also some command line options that we use to launch the service. There's a helper script there. You can also look at the contents if you're curious later. Anyway, we should be good. So let's move on. So let's talk about authentication first. By default, MongoDB doesn't come with any user password. Okay? You just connect and it will let you in, which is nice to test things, but obviously not something we would want on a production environment, right? There is something called the localhost exception that is used to create the first user, which means that you can connect only from localhost to the MongoDB server, and it will allow you to do a creation of a single user. Once you do that, then you will need to use that user from that time onwards, right? So normally you create something like root or admin, whatever. And any user that you create will go into a collection called system.users, which lives under the admin database by default. This is by convention, really. You can use you can create users in any database, but most of the people create them on admin, just like that. There is also, if you're using the Percona release, you have a helper script that we provide that will automatically create a register for you called DBA, and it will give it a password, a random password, okay? This script is called Percona server MongoDB enable auth. You don't need to run it for the purpose of our tutorial. We'll just work without a password to make things easier, but just be aware that you have that for if you are going to install this for a production environment eventually. The output you'll see is something like that. It'll say user has been created, and it'll give you the user and the password, okay? And you'll need to restart Mongo after, because also it makes the required changes in the MongoDB configuration file. As I said at the beginning, the configuration file lives under etc. It's called mongodb.conf, and it has some different sections. It's like a JSON kind of format, but the first section is the storage, where you define what will be your path for the database files, which by default is bar_lib mongo, and then whether you have the journal enabled or not. Okay, the journal is going to be required for crash recovery and consistency, so it's good practice to have it enabled, and it comes enabled by default, really. The next section is the system log, which is a file that MongoDB will use to record its information. You can also send this to syslog, for example, if you want. And there are some flags to control the behavior of the file, whether it should append to the same file or whether it will rotate each time that you restart the instance to a new file. That's up to you and how you manage your logging, okay? By default, it will just append to a single file. A couple other sections from the configuration file. The networking part, by default, it's going to use port 27017, and it will bind only to localhost, okay? So it will not be reachable from outside your instance. If you want to modify this, which normally is what you do, you can say like 0000, it will bind to every interface on the server. Or if not, you can just specify the IP of the interface you want it to bind to. Then you have the process management section, which controls whether when you start the service it will fork into a new process or no. And you can control the location of the process ID file, okay? Normally we don't have to change this. And finally, there's a couple other sections, but these are the basic ones. We have a security section, which is what you put when you want authentication to be enabled, which, again, by default doesn't come enabled. And the operation profiling controls the threshold for slow query logging. So in this case, with the setup that I have here, any query that is longer than 200 milliseconds will appear on the MongoDB logs, okay? And the slow queries, by the way, they are two places. We will see this, but the MongoDB log will always log the queries that are above the threshold. And there's also a profiler collection, which you can log the query inside MongoDB itself. So then you can query from within the database. All right. So after we get the database running, which we did, we have to connect to it. And for that, the tool we're going to use in this case is the Mongo shell that you installed. It's important that we know at least the basic stuff with the Mongo shell because, I mean, we don't know if there will be a graphical interface available, right? Sometimes you just connect to a server and you don't have the possibility to reach it. So the shell will always be installed in every Mongo server. So you know that you'll have a path to connect. The shell is nice. It's JavaScript based, so you can use any JavaScript inside it. And it features autocompletion, for example, and built-in help, which is nice. You can use the shell to run queries with the data, modifications, and also check the status of the server, as well as perform any administrative tasks. So, to connect via the Mongo shell, in your test instances, you can simply type mongo sh and hit enter, and it should connect. In case you had a password configured, the way to connect would be to specify first the authentication database, which by convention is admin, and then the user and password. Or there is another way, that is to connect using a string, a connection string that is called MongoDB URI, that is in a format like this, okay? You have MongoDB, then slash, and the user password at the IP address and the port. And the final slash with the authentication database. I think the latest one is the format that is more common nowadays, but any of them work. So let's try connecting now. And as I said, it should work if you just simply type mongo sh. Okay, and I mean, so you can try this now. Here's actually the first part. It will tell you here. You can see that even though I just said mongo sh with nothing, it automatically created a connection string in the other format that I mentioned. And it will tell you which MongoDB version it's connecting to, and which is the version of the Mongo shell, which now is a standalone product, right? You have also a link to the help page in case you want to know more about the shell. And at the end, you'll get a prompt with the name of the database. By default, it will bind it to test database. And if you type DB here, you can also confirm that it's bound to the test. And you can run here, show DBS, and it will list all of the built-in databases. As you can see, you have admin, which is the one with the users and all that. Then there is a config database, and there's also local, okay? Those are the built-in. And if you want to go inside one, you can say use, for example, admin. And as you can see, the prompt changes to admin. So now any command that we run will affect the admin database. And let's run our first query, which will be a simple one. The way to do this is, let's do show collections first. That will list all of the available collections inside the admin database. And you can see that we only have system.version, okay? There's no users here. Remember, we connected without a password, so there's no users.
How come the test DB doesn't show DBs?
Because really, you can use any DB. I mean, it's just a default of the Mongo shell. There's currently no test DB, actually. If you do, like, use test, and then I just, like, create a collection, like, can do the db.test call.insert, and I put a simple document here. You can see I didn't get any error, and now if you do show dbs, now test exists. So MongoDB automatically created everything, the database and the collection. So you don't have to explicitly create it. The first time you use it, it will be created for you.
So test doesn't entirely exist. We kind of started using it, but once we put something in it, it's real.
Right. I can do like use foo, for example, and it works. And then I can insert into a test collection inside the foo database, and then it works, okay? So it's, now the foo database exists, okay? Just creates everything for you. That's nice. And not also, because you can create things that you don't intend to sometimes, right? Cool. So, once we're connected, what we will do for this tutorial, sorry, yeah, let me go back. Yep, no problem. We're going to be using a test dataset that is available on the internet that contains a list of restaurants and reviews, okay? So, we'll need to run a command. I should have come up with a way to avoid typing all this, but apologies for that. You'll have to copy this wget command that is available here. This will download a JSON file with a list of restaurants and the reviews. And then what we'll do is we'll import this inside our test instance to play with this data, okay? So I'll give you a few moments to do that. Actually, I'm going to do it myself.
And we need to do this at the Linux prompt.
Yes, exactly. Sorry. Here. No. There it is.
And is the Mongo import also done at the Linux prompt?
Yes. So what this command will do, like the first one is just to download the test dataset, and the second one will import everything inside the test database in a collection called restaurants. And it has a drop there, so if the restaurants collection already exists, it will be replaced, right? So I'm gonna do it here. See if I can copy this. Oops, doesn't let me copy. I'll need to type it as well. Okay, I got it. Now I have to import. Sorry, let me go closer to you. All right, let's see. I'm going to run Mongo import now. So this is how the command should look like, okay? Right. Just a precaution in this case. but the instance is empty, so it shouldn't have anything. As you can see, it will say that it's dropping, and then it will give you the number of documents that were imported. So hopefully you got the same output. Everything okay so far? Any trouble? Cool. So this is, oh, one sec. This is how a sample document will look like. Basically, it will have the ID, which is like the primary key I was mentioning before, an object ID with a long string. And then we'll have a field with the address of the restaurant, with the building, the coordinates, street and zip code, the neighborhood, what sort of cuisine does it have, and then there will be an array with the different ratings. Okay, so each rating with the date, the grade, and the score that the user put. Finally, there'll be the name and a field called restaurant ID. So with this data, let's start looking at some basic commands. The first thing we can do is to try to insert a new restaurant. And for this, we'll need to get inside the Mongo shell again, use the test database, and run a command like this. Every command in Mongo will be db.collectionname.something, okay? So in this case, we want to insert into restaurants, and then between parentheses, you'll have to put the JSON that you want inserted. And if you notice here, in this example, I'm not putting all of the fields that appear in the document that I showed you before. Again, we can do anything we want. I could insert something completely different that is not even a restaurant, and like it will not complain. So you can go ahead and run this test, or put whatever info you want, just to get the syntax right. And then you can search for the document that you just inserted by doing find command. And again, between parentheses, you can put any field that you want to search. For example, if you say cuisine Chinese, it will give you all the restaurants that have this particular cuisine. So I will go also and do it. So first we'll connect. And it connected us to test again. This is just the default.
I got a notice that collection insert is deprecated. Choose insert one, insert many are both right. Is that just because it's not a feature?
Yeah, that's MongoDB 6 now changed this, but you can still use the traditional syntax. So let's say I just want to insert something like this. And another thing of the Mongo shell that I didn't mention is, as you can see, it will highlight the syntax, which is handy to know if you're missing something. And again, you can do like insert one if you want, just to avoid the message. I've been using MongoDB for a long time, so I'm still used to the old syntax, but yeah, it should still work. I'm going to try inserting the same, and you will see what happens. It just works. Like there's no unique constraint or anything by default. And by the way, you can see in the output here that it will give you the object ID of the document that you just inserted. So now, if I go and query, you'll see, well, my text is a bit big, so it's hard to see, but you'll get a lot of results, right? Because it's not just the ones that I inserted. What this will give you is a cursor, okay? Which you can iterate through. If you type IT, it will give you the next batch, and so on. Okay, so let's do that a couple of times, and you'll see all of the results, okay? I will look for the specific one I just inserted. Sorry, I forgot the semicolon. Is that the name that I used?
You did them as two separate, didn't you?
Sorry, say again?
You've got name Ivan in curly brackets and cuisine Chinese in curly brackets. It's not one.
Oh, right. Yeah, I just inserted two different things, actually. I didn't notice. So let's find it like this. Hold on. Okay, you can see now I found it because I made a mistake here. This is the nice thing about live demos. You always make a mistake. So I inserted two different documents, actually. Where's the syntax? Here. So I inserted a document with name Ivan and a document with cuisine Chinese. I should have done something like this instead. And now I have what I wanted to do at the beginning, okay? So other than the two fields that I had provided, we have the underscore ID now, okay? It's returned. Okay, so we inserted something and we know how to retrieve it. But as I showed you, you can insert more complex stuff like this. I mean, you can give all of the fields and specify, for example, arrays, which are using the, the syntax here, okay? It's comma-separated array, and so on. You don't need to insert this one, by the way, it's just to show you. There is a special operator, that is the dot operator, that allows us to search within a single document for any information within the embedded documents, okay? So for example, if we're interested to find any restaurants that are in a specific street, we know that the address, let me go back real quick. So the address is a document on itself, right? Because it has curly braces. So we'll need to get the field called street from the subdocument address. And the way to query something like that is to do a find like this, okay? You put the name of the field, dot, and the name of the other field. And then you can say, what's the value? So let's try something like that, just as an example. Okay, and we got something. Okay, here's the condition. Make sense so far? Cool. Another type of query that we can do is to search for documents that are missing a specific field. This is common to do because as we don't have fixed schema most of the time, you might be interested to know if there are some documents that are missing some information that should be there, for example. So in this example, we're querying for documents that don't have any grades, so they haven't been reviewed. And the way to do it is with an operator that is called $exists. And this operator accepts true or false, basically, and it's helpful for finding exactly this kind of information. We'll see a bit more about operators and which ones are available. But first, let's run this example. So that you can remember the syntax a bit more. So basically I say which is the field that I'm interested in first. And this takes some time to get used to, right? Because you normally think the other way around for a thing like this. You say, like in traditional SQL syntax, you say where some exists and then the query, right? Here's the other way around. You have to say first what and then exist. So it takes some time to get used to. And you can see how Mongo Shell also will give me a different color for the operators, right? They're in yellow. So something like this. And interestingly, I get my own document that I inserted before because I didn't put the field grade on it, okay? We have several operators available. This is just a few of them. We have operations for or, and so on, the logical operators, right? We have not. And we also have comparison operators. So we have less than or equal, greater than or equal. We have also the ones that are similar to the exist that we just used. We have not equal, in, and not in, okay? There's a couple more. They're all in the MongoDB manual if you're interested, but these are the most important for you to be aware of. Let's see how to use them. So far, we have been querying for just a single condition in all of our examples, but we can do more complex stuff, right? For example, if we want to find restaurants that are on a specific street or have at least a specific rating, we can combine the two conditions using the $or operator. And the way to do it is to use the operator first, and then in an array, put both of the conditions comma separated. So let's see how that works. So here I'm going to do $or, and then this receives an array as a parameter. And inside the array, I'll put my conditions. And I can also use subfields here with the dot operator to combine this with what we said before. And I can also nest operators. So here, for example, I want to score greater than something, so I can use the GTE operator. And you can see how this quickly becomes more convoluted, right? But it should work. I think I have everything right. Okay, so we got some results. And by the way, we can also do count here if we just want to know the number. So we got 5 results. Likewise, another example could be to check for restaurants that don't have any rating below 50. And the way we would do that is to combine the $not operator with the $less than as well. So similar to the one above. We can nest as many levels as we need to. Just remember the main difference is versus traditional SQL is that you have to put the operator first here most of the time. Okay, so as we saw, each time that we run a find command to query for documents, what we get back is actually a cursor. And there are functions available to check and operate against cursors. So we can do a loop like we do normally with any program language to check if the cursor has more values and then do something with that. So we have a cursor.next, the cursor.hasNext will give true or false depending on where we have more results or not. And then the cursor.next will return the next batch in the cursor. And whenever you run cursor.next, you will actually be calling server-side a function that is called getMore. So when you start working with the logs, you will see a lot of these getMore commands. So this means that you're iterating through a cursor, basically. Here's an example of how we can run some commands with a cursor. So within the shell, you can declare the cursor first, and then you can do a loop with the while syntax. This, again, is JavaScript. And, for example, print every element of the cursor. So let's give it a shot. So again, I'm declaring here my cursor. And I can actually check the value to see. It's empty because I made a typo. Now I have some stuff. So you can see that I got the results the same as if I run a find command. This is just the other way to do it. And I can do the IT here to iterate with the shell, or I can just run some JavaScript like this. Okay, so this will basically print every element, similar to what the Mongo shell does by default. Okay, but we don't get the IT here because we have control of the cursor. We're just printing everything. Of course, we can do more interesting things here, like maybe change a field on each document. But this is just for you to know the syntax. And there's a couple more things that we can do with cursors. We can sort the values. We can change the order of the information reported. And we can also query for multiple fields, right? So let's see what happens with each of these things. So if I run a find like this, it's going to return everything, basically. It's like a select without the word clause, right? I'll get every restaurant. So one thing I could do, for example, is say, okay, give me all the restaurants sorted by a specific field. For example, restaurant ID in ascending order. And you can see here that I missed the quotes, so everything is green, okay? That's useful because it lets me correct. Okay. So now I should get the restaurants ordered by their IDs, okay? And if I want them in descending order, instead, I just put -1 here, okay? Similar. And I can also sort by multiple fields, not just one, by specifying them comma separated here. So I could do like restaurant ID and then by cuisine, okay? Something like this. And this is how you order by multiple fields. Any questions so far? Okay. Let's see. Another common operation you want to do while you're doing queries is to limit the results. Okay, maybe you don't want all the results, you just want like the top 5 or something like that. There is a limit function for that you can apply to the cursor, and you can combine it with sort as well. For example, this is how to get the top 5. You run a sort by the field you're interested in, and then you do limit after. Okay, so let's see that in action. So I'm just going to get 2. Okay, and this is what I got. That's all about cursors. Any questions about this? Okay, for that you have to use projection, which we will cover in a second. But let me show you real quick. The way to do projection is to add another thing here, in the find. So the find actually has 2 fields, okay? I didn't show you the whole story yet. The first document that you provide is the condition for the find, okay, like the word clause. But you can also send another document like this, and here you will say which columns do you want in the output, okay? So like you would do select A, B, whatever. So in this particular example, if I'm just interested in the name of the place, for example, I can do something like this. So this will give me every restaurant ordered by restaurant ID, descending, cuisine, ascending. Okay, just the top 2 because I have a limit, and I will only get the name in the output. So let's see that, okay? Well, I do get the object ID as well. This is another thing. You can filter it out if you want, but you have to do that explicitly. If you just say you want name, you will get the underscore ID as well. If you don't want the underscore ID, you have to do this, okay? Oh, thanks. Yeah. There we go. So this will be on a few slides down the road, but just for you to be aware, you can filter which fields you're interested in by specifying them next to the find query. Any other questions before we move to the next topic? All right. What we're going to see next is how we change data. For this, we have an update command that is two parts. The first part is going to be the query that describes exactly which documents you want to update. And the second part is the change operation itself. So in this example that you see on screen, I'm querying for every document that has Manhattan, and I'm going to apply an update that increases the score by 1, okay? So let's run this and see what happens. Oh, and by the way, you can tap complete here. Like if you start typing and hit tab, it will automatically complete for you. Oops. Okay, let's see what happens. What did I do? Ah, yes. Thanks. Okay, so after you run the update, you can try that, you'll get well, other than the duplication warning, you'll get a number of documents that were changed. By default, if you run this update, it will just update one single document. This is how it works, unless you do something that I will show you in a second. One thing to be aware of with updates is that they modify the whole document unless you are careful. So let's dig into this example. Let's say that you're interested in changing this specific restaurant and updating the name. Okay, remember the first part is the condition. So I'm looking for restaurant ID with that ID. And the second part is what I want to change. So I might be tempted to do something like this and just say, okay, name equals something. Okay, for example, if the name was wrong and I wanted to correct it, then when you run this and you query, you'll get no results. So what happened here? I mean, the ID is gone. So if you instead query for the name, you will get the new document. And this is what happened with the update above. Okay? Basically, all the information in the document got replaced by just the name that you put. But you lost all the other fields. Okay? So be very careful with this, because it can happen. The way to do this kind of change, where you just want to modify a specific field of a document, but not overwrite the whole document, is to use $set operator, okay? By doing this, it will only change the name field and not touch anything else. If you just give a document as the second clause, it will replace the whole document with what you put there. Mm-hmm.
And you tell them to update MongoDB, but somehow that writes out all the other information.
Yeah, that's what it does. It's just how it's designed. I mean, I'm not saying it's the best design, but that's how they decided to do it.
I mean, updates in MySQL without a where clause are disastrous, but this seems like it's easy to propose something.
Yeah, it is.
And how is it different from the previous one? Because we didn't use $set, but we did increment a specific subfield.
Right. In this case, I did do a dollar operator. So any dollar operator will just cause to the specific field to be changed. That's a secret really for this. If I would just have said like grades 0.score equals a specific number, it would have been the same result. I would have changed the whole document, and I'll just get the grades field. So anytime that you do an update, make sure you do a dollar operator.
So it's actually just, instead of, you said without the set, it's just kind of replacing, it's making that update and wiping everything else.
Yes. So it's like a replace, really, more than an update. So every time you update, make sure to use a dollar function to do what you need to do, rather than just put the values explicitly that you want. Normally you would do $inc, $set, or something like that. So again, the lesson is don't blindly translate code from SQL to Mongo, because that might break things. Okay, as I said, if you run an update, normally it will just modify one document, unless you do multi-true, which is the last argument there, okay? There's also an update many function that has the same effect that I will show you in a second. But by adding this third document to the update with multi equals true, it will update every document that matches the condition, right? Borough equals Manhattan. So we can actually go and try this. Okay, so far so good. What did I miss here? I didn't close my curly braces. Okay, now what? One more closing. Yeah, thanks. There it is. Okay, so that's multi-update. There's also another way, another function that is useful for updating things, and it's called find and modify. This one also has the same issue as before, that if you put just a field and a value inside the update, it will overwrite the whole document. So remember to use operators, like $set in this case. So again, this is the same as before, just different function. To delete data, we have, of course, a method as well, delete one. There's also delete many. And the syntax is pretty much the same as before. It receives a document with the condition, and it will delete the documents belonging to that condition. If you just do delete, it will delete only one. And if you want to delete many, you can do so as well. Here's delete one, and here's delete many. Okay. You can try that if you want, just to get a hang of it. All right, so the next topic is going to be projection. This is what I showed you before. Basically, this is the same as doing select a column list from a table. And as you notice from when I ran the example, the underscore ID field will always be returned, even if you're projecting a couple other fields. If you want, you hide it explicitly by saying underscore ID equals 0. So let's see some examples. If I want just the name and the cuisine of a restaurant, I can run the query without the word clause in the first example and just print name cuisine, and remember the ID will be included also. If I want to return every field except ID, for example, I can do so by just projecting ID equals 0, and the rest will be included. And also, we can filter within a subdocument. So if we want to hide the coordinates, for example, the coordinates part of the address, but still display the street and the other information, we can do using the using the dot operator. Okay, you can say address.coord equals 0. So this is my previous example, when I run just the name. And just to revisit quickly, this is where I took out the ID, so that we only get the names. And in this case, I had an empty clause, but I could filter for something here as well, like cuisine, Chinese. Okay, there's no results in this case. Oh, never mind. This is case sensitive also. So this whole thing would be something like select name from restaurants where cuisine equals Chinese, order by restaurant cuisine, something like that. Any questions so far? I'm not sure you can, actually. I will need to check. I guess it depends on the collation also that you're using. But it's a good question. I will need to check how to do that. My first guess would be to just create the collection with a specific collation that is case insensitive. But I'm not sure if you can do it once you already have data in a specific collection. Yeah. Okay, next topic is going to be indexes. Before we dive into this topic, just a quick reminder of what is a B tree. Basically, it's the data structure that is used for most indexes. And it's a self-balancing structure, which means as data gets inserted, it will grow automatically. Basically, it's a structure where you have nodes in a tree that have pointers to two children, right? To the left, there are values smaller than the node, and to the right, values that are bigger than it. And then also at the lowest level, there's usually a way to move from leaf node to the next easily. So it's an efficient way to search for specific values, okay, within the tree. In MongoDB, every index is a B tree. And as is the case with all databases, whenever you create an index, you're usually trying to help you get your data faster, but you'll have some penalty for writes, okay? Because of a single write to the collection now transforms itself into a write to every index as well. And also the nodes of the index can become full and have to be split. So it could even be worse. When there are many splits, it can also add more writes. So like this is why indexing every single field is not a good idea, right? Okay. The basic types of indexes in MongoDB is a single field, which as the name implies, just to pick one of the fields and index that. You can create compound indexes with more than one field in a comma-separated list. And there's specific indexes that are multi-key, for example, which allow you to index an array, every value inside the array, and you can query efficiently that. For example, give me documents where the array has at least this value. And there's a specific indexes for geospatial coordinates as well to do searches. A couple of special indexes that don't exist in other places. You can do full text search with text indexes. In this case, what you have to do is when you create the index, say the description is text, like in this example, and then you can search for any words using the $search operator. So in this case, it will search for any store that has any of these words, okay? The other type of a special index is the TTL index, which, as I mentioned, automatically deletes the data based on a time condition, for example. You can also say, like in this example, delete every document that hasn't been modified in 1 hour, for example. So you can be creative with the conditions. Yes?
Does that tree
the document. Yeah. So it's meant to be used for collections that you're not interested in the old data, for example, and you don't want to run an archiving job all the time. You can say, I don't know, delete after 6 months, for example. And there's an internal thread in MongoDB that will automatically monitor that and delete it for you. Every collection will have an index built in to support the underscore ID field. Okay, this is a unique index, so you can't have duplicate values of the underscore ID, which makes sense because I told you it's like the primary key. But what you can do is, if you want, you can customize it to be something other than the object ID that you get by default. If you have any field that is a good primary key, or you're generating your ID values somewhere else, you can use those as ID and don't rely on the underscore ID that is built in. This is the syntax to create the indexes. There's a create index function, and then you have to say which field you want. It could be a single field. You can create also the index in reverse order. And you can also index just a subdocument, like for example within the address, just the building. And you can also index multiple fields by putting them separated by comma. Once you create an index, one common thing is to check whether it's being used, right? So let's dig into that topic. And for this, we have the explain function that you can append at the end of the query, and it will display a lot of information about this query. In this particular case, I'm interested in just the query planner information and the winning plan field, okay? So this is why I have this dot at the end. If you just say explain, you'll get the output, but also a lot more stuff. By doing this, you can quickly see which is the execution plan for a particular query, okay? If you see a collection scan, it means that it's basically doing a scan through all of the documents in the collection, which is like you'd call a full table scan in other databases. So in this case, it looks like there's no good index for this particular query, okay? So what we would do in this case, our query is borrow Manhattan, so we should probably index that specific field, right? And this is how we would do it. And now we go check the execution plan again after we do this. And as you can see, it changed. And now we see that it's doing IX scan, and we also get the name of the index, okay? So now it should be more efficient, right? Let's quickly try this to see if what I said in the slide is the truth. So let's do the query. I'm just going to run the explain as it is. And you see that you get a lot of information, okay, about the version of the server and a bunch of internal stuff. So I'm just interested in this case in the query planner. Winning plan. So you can see that it's doing a collection scan as expected. So now let's create the index. And as I didn't say the name, it just generated a name for the index. It's going to be borrow_1. But we can customize this and put our own name if we want to. So let's run the command again. And as you can see, now it changed to an IX scan using the index that we just created. Okay. Hopefully, if you're following, you got the same in your laptop. You got something different? Okay, let's see. So, yeah, be careful if you made any typo, because you could get an index created on a field that doesn't really exist. This can happen. Yep, that's the MongoDB philosophy. Everything okay for the rest of you? Cool. Awesome. So just a quick recap about the indexes. They are good for making queries more efficient and faster, to avoid things like reading all the documents in the collection, performing a collection scan. Another thing that they're good for is to return the results already pre-sorted. Remember that the index key will sort documents when you create it, so you avoid having to sort them after you retrieve them from the database. And also you can create the index with a modifier unique true, which means that you'll get validation that no duplicates of that field are created, okay? Any questions about indexing?
They have the equivalent of like functional indexes. You know, say you have a date and you want to be able to grab the months out of it.
Yes, there's functionality to do functional indexes. There's also some others that I didn't put here in order to not overcomplicate things, but you can do partial indexes as well. So just index the documents that have a specific field with a specific value. For example, it's common when you have a jobs table where you have jobs that are pending and jobs that are completed. Probably you have, I don't know, tens of jobs that are pending and like thousands that were completed. So you could index jobs that are just pending and quickly retrieve them rather than just index the whole number of jobs. That's one use case. Yep. Okay. Our next topic is going to be replication. In MongoDB, replication is based on a concept called replica set, which means a replica set is one or more servers that contain exactly the same data, okay? And you can access them as a single unit using a connection string. So it's transparent for your application. You just give the connection string of the replica set, and you don't really know which server you are connecting to, okay? Of the ones that are members of the set. MongoDB will automatically put one server in the primary role, which is the one that will be receiving the writes. And you can use the rest of the servers for high availability and also for offloading expensive queries from the primary. Another thing that comes with replica sets is initial sync is automatic. So when you add a new server to the set, the data will be cloned automatically without you doing anything. And of course, if the primary server fails for whatever reason, MongoDB will automatically pick a new primary from the remaining servers. And this will all be transparent to your application. So for this particular reason, there is an internal quorum mechanism to elect the primary. So you need at least 3 nodes for a replica set, at least for production, okay? So that if one goes down, you still have 2 that can talk to each other and figure out, like they are a majority, so they can elect a new primary. This is how it looks like when you're dealing with a replica set. You'll have your client application, which is running the MongoDB driver, and it's sending reads and writes to a primary server. And then you'll have the 2 secondary servers that will get the data via replication without you doing any configuration, okay? So this is the way to create a replica set. What you have to do is connect to one of the servers that is going to be like the server with the seed or the initial data, and you do rs.initiate. This will convert this single server to replica set mode, and then you can add more servers to the replica set by calling the rs.add method. And in this case, host 2 and host 3 will get automatically all the data that is in whatever server you run the initiate command. Assuming it's host 1, let's say, the rest will automatically get the data, and host 1, of course, will become the primary because it's the one you bootstrap. This process that I described is called initial sync. So any nodes that you add, again, will get a copy of the data. And the donor node is detected automatically or picked automatically, but you can also control if you want to use a specific donor to avoid impacting the primary server, for example. You can specify exactly which node will be the donor. And also you can automatically make a server resync by cleaning all the data inside the MongoDB data path and restarting MongoDB process. When a server that is already a member of the replica set restarts without any data, it will detect that it's a member of the replica set and begin initial syncing again. Okay? So it's very easy to recover a member. For example, if there was a disk problem, you just replace with a new disk and start it again, and it will automatically sync.
Is there a way to control the rate at which that migration happens, maybe to help lessen the effect on the...
You mean if there's a way to control the bandwidth usage, that kind of thing? Mm-hmm.
That has some effect on the primary node, correct?
Well, it depends on which server gets picked as the donor. If it's the primary, yes, you'll get some impact because the primary will have to read all the collections from disk to send them over. Normally, MongoDB is smart enough to pick a secondary, but if you just want a specific server because it's, let's say, in the same availability zone, for example, you don't want to pay like inter-region costs or anything like that, you can do so. Okay. There's a couple of methods to check the state of the replica set. The most important one is called rs.status, and this will print the members of the replica set and what is the status of each of them, as well as some extra information like what is the date and time of the last change of primary. So So you can monitor this to know if you had any failovers. Basically, replication works by using something called the oplog, which is a collection that lives under the local database. So you can even query that collection to see what's inside. But you will get one document created for each write on the primary. This collection is capped, so by default it will use 5% of whatever is the disk size that you have, but you can change the size if you want, okay? And an important property of this collection is that each entry is idempotent, which means you can reapply as many times as you want, and you'll always get the same ending result. So that is for consistency, to have good consistency. So these oplog entries get created, of course, in the primary, which is the server that is receiving the writes. And then every secondary member will connect to the primary over the network and fetch these oplog entries to apply them locally. And this apply phase happens in parallel by default, so it's quite efficient. However, if for whatever reason the secondary members get too far behind, there is a mechanism called flow control that will cause the primary to throttle the writes, okay? Which will, of course, increase the latency that your end users perceive, right? So we want to monitor for this and try to avoid it as much as we can. This mechanism can also be disabled, right? If you just don't care that your secondaries get too far behind for some time, you can turn it off. So it's not strictly mandatory, but know that it exists. By default, the threshold for this flow control is 10 seconds. So if a secondary gets more than 10 seconds behind, you will start seeing throttling. And I will show you in a moment how to see this if you have monitoring with PMM. It's very easy to see. Another method that is useful is rs.printReplicationInfo. This will display some properties that you see here. For example, what is the configured oplog size and how many hours of data you currently have. So in this case, you have 26 hours. Remember, it's like a circular buffer. So if you have many writes, the oplog window will shrink more and more, and eventually you could need a bigger oplog. Think about what would happen if one of the secondaries went offline for whatever reason, and then you needed to start again and resync. And if it was down for more time than you see in the oplog window, it means that it will not be able to catch up and will have to be completely cloned again. Yes, initial sync will happen automatically, but you'll have to pay the penalty of copying everything again. Maybe if you have like many terabytes of data, it's complicated, right? So ideally, you want to monitor your oplog and make sure that you have enough time to recover from a small outage.
Can you control the amount of parallel workers?
No, that's not a tunable that is exposed at the moment. Yep. But it will be nice. Yeah, I'm sure eventually that ability will come, but for now it's not documented, at least. I don't know if you go into White Tiger internally, you can maybe change something, but MongoDB doesn't expose that. Another concept when we're dealing with replica sets that we need to be aware of is called read preference. And this controls basically where your queries will get data from. Remember that in a replica set, you don't connect to one specific server anymore, but you just connect to all of them, right? To the replica set connection string. So by default, when you do a query against a replica set, you'll get your data from the primary. But if you have many queries, or you have maybe some heavy queries that you want to offload, you can send them to secondary members by specifying secondary read preference. Just be aware that replication here is asynchronous, so you might get stale data. So if you need some read after write semantics, you probably should stick to primary read preference. Yeah, that too. But even within a few milliseconds, you could get stale data. Here are the options available for the read preference. Again, by default, it's primary, but you have another that is called primary preferred, which means I prefer to read from the primary, but if there's no primary available, because we're in the middle of a failover, for example, where temporarily there will be no primary, I still want the query to succeed. So in this case, I would say primary preferred. So it will go to the primary, but if there's no primary, then we'll go read from a secondary. You can also use secondary and secondary preferred, which means that if there's no secondaries, it will go to primary. And finally, there's one called nearest, which basically goes against the member of the set that has the lowest network latency to the server that is doing the query. So the Mongo driver will poll all of the servers in the replica set and store the latency that it has, like the ping, the result of the ping command, and choose the one that is the lowest ping. And the way to configure this read preference is to call the set read pref function from within your application or from the Mongo shell. You can also do it, and then run your query, okay? And this will respect whatever value you put. No, you have to set this per connection, actually. Yeah. I mean, you can do it, yeah. You can force it in the connection string directly. If you want, you can do that. Or you can do it like connect with a specific value and then for a specific query, change it and then change it back. Like it's possible. Another topic that I don't want to dig deep, but just be aware that it exists, is the read concern, which is different from the read preference, okay? The read concern allows us to control the consistency of data that we're reading. So by default, local is the value that is used, which means that whatever data we read from the local node that we're connected to, either the primary or secondary, will be returned. But if we care that we're reading data that is completely consistent, we can set this to majority, which means that the documents we get back are committed by a majority of the nodes, okay? Otherwise, it's possible that you read from a secondary and maybe that data is rolled back after. So be aware that these options exist to control that kind of scenario, okay? If you just care about reading safe data, majority could be important. Of course, it's slower than reading local, which just means read from the one server. When you use majority, you have to go check that the other servers also have that data. I mean, the driver does it for you, but it will delay the result a bit. Any questions so far? Right, that is configurable, the read preference inside the connection string. When you connect for the first time, you can set a default read preference, and then you can override that whenever you need. Like maybe you start with some read preference, and for some specific queries, you change it, do the query, and then change it back, for example. You have that possibility.
Does that also show up in like in the
That will show when you do, I think, db.connectioninfo, you call that method, it will tell you the current setting, yeah. Because it's really not a property of the cluster itself, but more of the client, you know.
How does mirrors work? Just because, like, it would seem like you were connecting, depending on what you were connected to, how was it aware of the other ones in the place?
So what the driver does is when you connect to the replica set, you will give all of the members in a, or at least one member, and the others will be automatically discovered by the driver. Okay? Yeah, you can put all of them, but as long as you put just one, the driver is smart enough to figure out the rest of the members. And then it will start pinging them and storing the result of the ping inside the driver code, and then select the one with the lowest ping. No, I think every client has to do it, yeah. Routing? Yeah, there's the MongoDB router, which is used, but just for sharding. I will show you this in a second. When you're doing with the connections to a single replica set, you don't need to use the MongoDB router. What you can do is create, like, for example, a DNS record, and just connect to that from your application, and then that DNS record can result to all of the members, for example. For a production environment, yes, you would need a minimum of 3 servers for the quorum, but you can bootstrap a replica set with just one member if you want for testing or whatever. Yep, it still works. Mm-hmm. I'll dig into this in a second also. Which leads me to the next topic of high availability. The idea is that based on the replica set functionality, we'll have high availability out of the box. Again, the driver that is installed on the client side will automatically perform this discovery, like I was mentioning, and will handle also the failover for you. So in case one of the secondary nodes gets promoted, the driver will know and start redirecting traffic to it. So it's important on a replica set to distribute servers geographically, or at least, at the very least, in a different availability zone, right? So that zone outages don't affect all our cluster. Since, again, there is no protocol like other technologies that is affected by the network latency, it is okay to do a replica set across geographical regions. The only thing is if you're going to be writing data and you want those writes to be confirmed by more than one server, and the other server is in the other coast, is probably going to affect the latency of that write. But by default, if you just care about writing locally, you can geo-distribute servers as much as you want, because there's no protocol limitations like other clustering technologies where nodes have to be close to each other, because otherwise all the writes suffer. Which leads me to the concept of write concern. And this actually means how many nodes you want to acknowledge a write before the result gets sent to the end user. By default, this is, since MongoDB 5.0 is majority, which means that at least, let's say we have 3 servers. At least 2 of them will need to confirm the write before the acknowledge is returned to the client. Okay. We also can change this per connection and set other options like 0, which means just fire the write and forget, which is of course the fastest option. Or we can do W1, which means at least one server, the primary, has to acknowledge before we return. So if maybe you're doing like a massive initial sync of data, you don't really care about the acknowledge. I mean, if something fails, you can fix it later. You just do W0 and make it insert as fast as possible. And if you write in a financial transaction, maybe it makes sense to use majority, or even you can use a custom number. Like if you have 5 nodes in the replica set, you can say W5, which means all the servers have to have the right, okay? So it's nice to have that flexibility. How the high availability functions is there is a heartbeat happening every 2 seconds by default. So if the secondary members detect that the primary doesn't answer for at least 10 seconds by default, which again is configurable, it will trigger an election, and the remaining nodes will vote to decide which member will become the new primary. So this is what will happen. Okay, our primary is gone. The 2 other secondaries still see each other. So one of them is promoted, and now we'll have a 2-node cluster, or replica set, to say the right word, with a primary. Okay. If eventually the old primary comes back, what will happen is it will rejoin the set as a secondary, and if there are any writes that the old primary has that haven't been propagated to the rest of the servers, they will simply be discarded, okay? So that is something to be aware of, right? And a reason why you might want to tune the write concern as well, to reduce the probability of rollbacks. Because if you wrote with W1 and then the primary dies, maybe that write didn't go to the rest. So if the primary fails, you will have missing data, okay? I mean, MongoDB will continue, but that document will not be there, okay? Make sense so far? Yes. Any rollback documents will be stored on the primary in a specific place. You can go manually inspect and see what you do with that data.
Is there any possibility that the primary and secondaries can't communicate, and then, but at the same time they both think they're the primary and split brain?
Right. I mean, that's because that's the idea why I said you need 3 at least. Every time there will need to be a quorum for a new primary to be elected. So split brain is not really possible in this case. That's a question?
So basically, if you're having any network connectivity between the different servers, you can start switching primaries pretty quickly.
Yeah. I'll show you that in a second as well. So what are the factors that trigger an election? First of all, like I said, if the primary doesn't reply to the heartbeat for at least 10 seconds, again, configurable value, then this will trigger an election. Whenever you add a new node to the replica set, this will alter the quorum, right? For example, we have 2 nodes, we're adding a 3rd node, so now there's 3 votes. So that triggers an election, which doesn't mean that there will be a change in primary, right? I mean, if all the nodes can see each other, the primary will still be the same. But whenever you add a node, it will be checked again just to make sure that we still have a quorum. And any of these commands that are used for replica set maintenance will also trigger an election. Initiate, which is the one to bootstrap the replica set for the first time. A step down, which you run when you want to manually demote the primary for maintenance, for example. And reconfig, which is a command to use to alter any properties of the replica set. Okay. So all of these will trigger an election, which doesn't mean there will be a change in primary. It's just that it will be checked. No, if that happens, it will go to secondary mode automatically, and the driver on the client side will fail over to whatever new primary gets selected. if you run the rs.status from the remaining two nodes, it will say like unreachable on the primary. But if you connect locally to the old primary, it will say secondary now. So it will automatically demote itself. Okay. So during a change of primary, what will happen is that writes to the cluster are frozen momentarily. You can still read normally. And any of the remaining healthy nodes will talk to each other to elect the new primary. Like I said, if there are any non-replicated operations, they will be discarded. And that's why you might want to consider using write concern majority for any writes that are critical, and you want to make sure that there are no rollback. Another thing you can do with a replica set is establish priorities for the members. The priorities affect which member gets picked in an election, and MongoDB will do a best effort to promote the member with the highest priority. You can also tag specific members with priority 0, which means they will never be elected. Okay? Normally, you have a primary data center, and the nodes in that DC, you normally want them to be primary unless the region is down or something like that. So in that case, those nodes, for example, you could give them priority 2 to say something, and the nodes in your backup DC can be priority 1, which means that every time the algorithm will prefer to promote a node in your main DC. And maybe you have a node that is less powerful, or that you want to keep like a few hours behind just to recover from a user error. For example, you can do that, have a delayed member, but you don't want that one to become a primary because it means that you will have 4 hours of rollback, right? So in that case, you could put that node as priority 0, and it will be ignored for election of a new primary. You can have a lot of nodes in a replica set, but a maximum of 7 members that vote for primary elections, okay? You can also alter the number of votes that each node has, but it's not something that I recommend. And also the MongoDB manual mentions that probably it's not a good idea to mess with that. It's better to rely on priority to control elections. So the nodes that you want to have high priority, just bump priority on those, but don't modify the number of votes. And again, it's a good practice because of this quorum mechanism to always have an odd number of voting nodes. That means 3, 5, or 7, basically.
So if you have 3 nodes, one dies, you now have 2 nodes that are voting. Isn't that even voting?
Right. That obviously is not an ideal situation. It's supposed that the old node will come back, but still the 2 remaining nodes will know that they are a member of a 3-node replica set. So, I mean, the majority is 2 out of 3, so they can still elect a primary. If you have 4 nodes, let's say, and 1 is unreachable, in that case, the other 3 can still elect a new primary as well. But if you have 2 nodes in DC1 and 2 nodes in DC2 and the connection gets severed, you have 2 on each side. So no one can elect a primary in that case. That is why the odd number. You can also tag specific sorry, one question.
I'm just curious, what's the tiebreaker in your 3-node scenario? You down to 2, like you're not going to fight each other for primary status where each refuses. But what's the progression before saying like you should be primary as opposed to me?
That's a good question. I'm not sure how the nodes figure it out between themselves. I would need to check the algorithm. But
if they were human, they would never relent. It would be a stalemate. But computers have that something.
yeah, that's a good question. I'm not sure about the internals of that specific, but yeah, it would be nice to check the source code to see. I hope it's not the lowest ID that wins. We'll see. You can also have hidden members. These are completely invisible to client applications, so you cannot send any application traffic to them, and they can also never become a primary. However, they may vote in elections and also participate in acknowledgements of right concern. This, for example, could be useful when you are in an upgrade scenario. Let's say you have 3 nodes and you want to move to a newer MongoDB version. One possible approach is to provision 3 more nodes and add them to the cluster. So temporarily, you'll have 6. Okay? And then you cut over to the new nodes, and you want to keep the old ones just in case for some time. So you can set the old ones as hidden, and they will be completely invisible, but you'll still have them in case you need to switch back to them for whatever reason. Like I said, you can have also delayed members. For example, if somebody drops a collection by mistake and you don't want to restore the whole replica set from scratch, and you have a delayed member, you could recover it from that one. And these members have to be hidden, okay? But they may vote in elections. All right, and that is all for replication. Before we move to monitoring, any questions?
So I'm assuming the 3 nodes have to be on different virtual machines or whatever.
They should be, yeah. That's a good idea, probably. Normally, if you're in the cloud, the common scenario is to provision them in a region in 3 different availability zones. Or if you have data centers, just one on each. And perhaps you have a 3rd site with just one node to break the tie in the cloud, for example. So 2 DCs plus a cloud environment. Okay, so in terms of monitoring, there's a couple of solutions available. The MongoDB solution that is offered is the Ops Manager or Clouds Manager, which is quite expensive. But luckily, Percona has PMM, which you can use free of charge. It's based on Grafana. And there is also a few other options, like Datadog, or some people use New Relic, but they are less advanced, I would say, than the other alternatives. In the case of PMM, this is a client-server solution. You have an agent that runs on every database host, that runs a collection of metrics, and then sends that to a PMM server that receives all that data and stores it for you to consult via the web interface. You can deploy PMM server with a one-liner script that basically will install Docker and then pull an image and start it. So it's just a single command. You can also run this script in interactive mode to customize a few things, but normally there's no need for that. So it's quite easy to get started. And then for the client, there's a couple of steps. First, we have to configure the Percona repository, which we did for our initial installation, and then install PMM client package from there. Once we do that, we connect the client to the server and enable collection of the MongoDB metrics. So let's see these steps in a bit more detail. Percona repository, this is the same command as before. There's also an alternative for Ubuntu-based release. In this case, we have to enable the PMM client repository for this particular client and install it with Yum, same as before, no difference. Once we have the package, we will need to point it to the PMM server, which listens over HTTPS on port 443. And with this command, you will point the client to the server. You have to say the user and password and the IP address or host name. Okay. And if you're using self-signed certificates, it's a good idea to include this flag as well. There is a custom role that we create for the MongoDB user to be able to export all the metrics. I'll just leave this in the slide for you to review. Basically, it requires a few permissions, like to list the collections and the indexes and so on. And then when you have that role, you can create a PMM user like this with our custom role plus a few other privileges. All of this is in the PMM documentation. Finally, we have to enable the collection of data, which is done using PMM admin command line tool. And you have to say that you want to add MongoDB metrics and specify the user and password that we just created, as well as the host name and port. Normally, this will be localhost because you install the agent on the same server as MongoDB. And this is how it would look like after everything is configured. You'll get a Grafana page that shows some information. I will show you this quickly. I have a PMM instance here. So this is what you see when you log in for the first time. It will give you a summary of how many systems you have monitored and so on. And if I click here on the MongoDB logo, I'll get a list of dashboards. The one I like to start is the REPL set summary for this case. That gives us some information about the replica set. I think the notes I had monitored here are gone for a few days. So I'm going to pick a time frame here. Okay. So as you can see, I have 3 nodes here. And I can see which one is the primary. And also, if there was any change in role, it will be visible. You have the version, you have the number of nodes, and the details about the operations, for example, of each node. I can go a bit deeper here by going to where Tiger details. This dashboard will have low-level information about the WireTiger operations. Let's see if I can show you something here. Yeah. So as you can see, it's very easy to focus on a specific time frame here by doing something like this. It's very fast. And there's plenty of things available to monitor of the low-level metrics. Remember that I mentioned before that if flow control gets engaged, the writes on the primary will be throttled, right? If that is happening, you will see this graphic, queued operations, it will have a spike, okay? So it's very easy to see. In this case, we don't have any. And you can monitor a lot of things, really. Also at the operating system level, I can go here. Oops.
What are some of the most important things to monitor? I know one of those things is like the ratio of scan to return rows, things like that.
Mm-hmm. Yeah, that's a good one. I would say that concurrency tickets is an important metric. This should never go to 0, because when it goes to 0, it means that no more sessions can make queries until there is a ticket available. This will also show, like if tickets go to 0, you'll also start seeing queued operations rise. So the queued operations is one to keep an eye on, because it can grow for many different reasons. Another common thing is the eviction from the cache. Like if there's a lot of evictions, it's probably that either the cache needs to be bigger, you need more memory, or you need to figure out how to like reduce the number of data your working set, like basically. What else? Well, here you can see also rollbacks, which is interesting. You will always see rollbacks here, even if there's no document rollback, because some internal operations of MongoDB rely on rollbacks. But if there's a spike, it might indicate something happened. And if you want to know more about this, I recommend the tutorial in the afternoon that will have more information of this topic. No, that's another person, yeah. I'm not sure actually if it's the same room or not. I'm sorry, I can check and confirm with you. The final thing I want to show here is there's a couple more things you can do, like alerting. You can manage alerts from here. There's a backend management also. So you can schedule backups for your MongoDB cluster directly from PMM. Okay. So in this case, I have a daily backup configured, and here I can see a list of backups. This will create our backups on an S3 bucket. Okay. And then I have the ability to do a restore here if I want to. Okay. And of course, I have the ability, well, this is the backup location, and I have a history of restores performed as well. You can perform, well, I'll show you a bit more about this in a second, but both physical and logical backups are possible in Percona distribution of MongoDB. And finally, the query analytics section is one of the favorites, because it allows you to see information about slow queries in almost real time, okay? So let's see if I can see something here. Let's say last 90 days. Okay. Well, I have some queries here from just the internal Postgres database, none from Mongo, unfortunately, but I mean, the functionality is the same, really. You can click on a query and get more information, as well as query examples, and the execution plan. In this case, they are just internal queries, so there's not that information, but you can get like the collection scan and an index scan. There's also alerting, like I said. And let's quickly talk about a bit more about backup and recovery. So for backups, the first option is to do a logical backup. And for this, you have a few tools available. A Mongo export tool will allow you to export the data in text format, so you can move it to a different platform, for example. MongoDump will export a BSON format, so it's faster if you want to use that to restore to MongoDB, but not to move data to another platform. And there's also Percona Backup, which can use MongoDump, but the thing is, MongoDump is meant to be used for a single server. If you use Percona Backup, you can get a backup of a cluster with a replica set or sharding automatically for you. Okay? Then there is physical backups. They are available in Atlas as a feature, also in Ops Manager. You can also take snapshots yourself, for example, by locking MongoDB for writes and then calling whatever snapshot utility you have. And finally, Percona Backup offers a feature called Hot Backup, which relies on the MongoDB engine directly. So it's quite fast, and it's not available in MongoDB community, okay? So MongoDump is a logical backup. You can do full backups, or you can filter by collection. And it will back up both document data and indexes. This is an example of how to use it. Basically, you say what is the DB and the collection, and provide the user and password, and that will create a directory with the backup. By default, it's called dump. And then the other operation would be Mongo restore, that will take the backup that you just created and import the data again. And it will also rebuild any indexes that existed when you took the backup. There are some filters you can use also. And there are some internal collections that are ignored in this kind of backup, okay? Like the system profile, for example. This is how you use Mongo Restore. You have to say the namespace that you want to restore and whether you want to map that to a new namespace or not. For example, if I have a backup of my training.testcall, I could want to restore this to a separate collection instead of overwriting the one I have, so you can do that. And then, like I said, in the Percona backup, you have both logical and physical backups available, and you also have point in time. So Percona backup will stream the uplog over time. It will create slices of the uplog, so to give you the ability to restore to a base backup and then roll it forward to whatever point in time you want. This kind of backup is supported only on MongoDB 3.6 and newer, okay? And it does require a replica set. You cannot use it for a standalone server because it requires the uplog, which is not in a standalone server. There is a backup agent that you install on every server, and it requires a MongoDB user to connect, and that is how PBM takes the backup. And then you can store the resulting backup in an NFS volume or an S3 compatible storage bucket. So it works also with non-Amazon clouds. Inside PMM, as I showed you, you can schedule the backups as well and manage the inventory and trigger a restore operation, or you can do it directly from PBM command line as well. This is how it looks, what I just show you in PMM, so I will not spend much time with this. So the final topic for today is going to be an introduction to scaling. Yes, there's a question. So you need either a bucket or an NFS storage because of how PBM works.
The question is, can I do a backup without that and without logging file system?
Without locking the file system, you mean? Yeah, definitely. The way PBM works is it doesn't require any locks. You,
If I don't have a shared file system, I don't have an S3 or an NFS.
okay, so the NFS storage or the bucket is just for the backup. It doesn't mean that you need to have your MongoDB on NFS. I think that's where the question comes from.
The question is, if I want to do the backup, but I don't have the shared system, is there also a possibility?
No, at the moment you need any kind of shared storage. It's because the backup is really coordinating all the nodes together, so which one will do the backup. It's not that you back up a single node really, but you just back up the replica set as a whole. So any node could be selected for the backup. That's why you need the shared storage. But that can change in the future. I mean, if it's something you're interested in, you're welcome to open a feature request for us to consider. Any other questions about backups? Okay, so our final topic is going to be a quick intro to how to scale with MongoDB. When we're talking about scaling, we have to consider vertical and horizontal scaling. Vertical scaling just means getting a bigger server, and horizontal scaling means adding more servers of the same size, let's say. And we also have to consider if what we want to scale is the read or the write part of our operations. If we need to scale the writes, MongoDB offers sharding out of the box. Sharding means that we take one collection, for example, that is 1 terabyte, let's say, and we partition it in several different pieces. For example, in 4 256 gigabyte slices, okay? And each of these pieces will be stored in a separate shard, okay? I will explain a bit more in a second. So first we begin with a single MongoDB server. The next level is we evolve to a replica set where we will have secondary nodes that we can use to send read traffic to, for example, to scale reads, okay? And if we need to scale the writes, we would add, we would convert from a replica set to a sharding topology, and we need to introduce a couple extra components for this, okay? So our client will no longer connect directly to the replica set, but now it will connect to a MongoS router, which is a separate process that will be in charge of directing the connection to the appropriate place. So in a sharding setup, there is a replica set called config servers that stores the distribution of the data. So going back to our example, these 4 pieces of data, we have to know where they live, okay? So the config server will have that information. So whenever you send a read query to the MongoS router, it will interact with the config server to ask where exactly is the data located, and then it will actually be redirected to the specific shard. So each of these shards will be a replica set, okay? So think about the scenario we were covering before. Our 3 servers are a replica set. They would become shard 0, and then we add another 3-node replica set that will become shard 1, okay? And half the data will be on each of them. But this will be transparent to the application because the application will still connect to a single place, which is the MongoS router, which will take care of figuring out where the data is, okay? So again, if we want to scale reads, we can just do so with replica set. We don't need sharding. We can use secondary members to introduce more queries, okay? And also to reduce the load on the primary. And if load is still too high, we can always grow to more secondaries. We can have a lot of them. And again, the way to use them would be to set the read preference to secondary and then send the query. In the case of sharding, again, the idea is distribute data across multiple servers. A good idea if you have a very large data set or high write throughput, as we discussed. And of course, the trade-off is that you'll have more things to manage, okay? So the complexity will increase for you. And this is how it looks like, zooming in a little bit, okay? All our application servers will be running the MongoOS router, or there is another possibility to have like a dedicated level of MongoOS routers behind the load balancer or something like that. But the basic idea is you just install locally the MongoOS router on each app server, and then you connect as usual with just a single endpoint, okay? Which will be the config servers for the router. And the config servers will redirect the client to whatever they need to operate against. So to sum up, the data is always accessed through the MongoOS router. You don't connect directly to the replica set anymore. You have the config servers with the metadata of the sharding, so it will say where exactly each part of the data is. Each of the shards that you have will be a replica set on its own, and the sharding is done at the collection level. That means that you shard a specific collection. It's not that you shard the whole thing. You pick a collection, you say, okay, I want to shard this by specific field, okay? And then MongoDB will take care of the rest. So to shard a collection, you have to pick a key. Again, there will be one or more fields of the document, and that field requires an index. Once that is done, MongoDB will partition the data into ranges or chunks, which have a lower and an upper bound, okay, based on the shard key values, and then the data will be split. So, for example, if we want to shard the restaurants collection that we were using, we can create an index first on the zip code, for example, if that's going to be our sharding key. And then we can say sh.shardCollection, and then give it the sharding key, and that is all that we need to do, okay? So what will happen when you do this, again, all of this will be transparent to your application, but behind the scenes, the MongoOS router will know that our collection now lives partly in shard A and partly in shard B. So it will do whatever it needs to do to make sure to give you back the results of whatever operation you specified. Make sense so far? If you're interested in sharding, I also suggest you attend this afternoon tutorial, because there will be more about this, okay? This is just high-level overview. So clustering is hard because, again, we have more components to manage. In the case of sharding, we now will have the MongoOS routers and our config server replica set. Taking backups is more complex because we don't have to deal with a single replica set now, but just all of the shards plus the config servers. Luckily for you, Percona Backup will handle that automatically, so you don't have to deal with getting a consistent point in time across the whole infrastructure. Sometimes planning is hard because you start with the shard key and then down the road it turns out it was not the best decision. Also over time it can change, like at the beginning maybe you're writing just a few documents, and then you grow, and now you have thousands. So the good thing is newer MongoDB releases allow you to reshard also, which is still expensive, but possible, which was not before. But it's a good idea to pick a good shard key from the beginning, keeping in mind how much data will grow in the future, and also what kind of queries you will do. Because if for every query you will have to run it across all of the shards at the same time, perhaps it's going to be real costly. And if there's another way where you just target your query to a single shard at a time, that would be probably a better way. So that is all for today. Are there any questions about sharding on any of the topics we covered?
What are some of the more common sense sharding strategies you see?
Well, there's many. Some people, for example, shard, keeping in mind like the hot data is in a few shards, and then the archive data is in other cheaper hardware, for example. Others just do with the client ID, for example. The problem with client ID is that if you have just one big client, you end up with a lot of data in some shards and the others are empty. So there's many strategies really. It will depend on the use case. Any other questions? Yeah, you're welcome. Thank you for coming.
Are you supposed to talk about rating the talk?
They didn't say anything. I guess there will be a way to rate the talk in the application, right?
If you're on the app, I think you can come into this session and rate the talk, and we really like the feedback, so we can turn that into a better time next year.
Thanks. By the way, if you want to keep playing with the instances for a couple more hours, they will be available, so feel free to use them, okay? Probably at the end of the day today, yeah.